okay? We'll go with that. Yes, it was a weak attempt at a Star Wars joke, so we'll give it a shot here. Last year, when we were doing some things at Investor Day, we took a look at some surveys around Gartner, Microsoft, Substack, et cetera. And there were some numbers that were thrown out for 2024 in terms of like 44% of people would be using, generative AI in their, coding things by the end of 2024. And that maybe somewhere on the order of 50% of knowledge workers would be using generative AI by 2030. That was the original prediction like a year ago. And what we found this year is that we're already at 75% of global knowledge workers that are using it in some context. And 3/4 of all developers are using this in some sort of code. And why is this important? Well, because at the same time last year, what we were really focused on and what most of the messages were focused on was the training aspects. And so when we think about training and the impact to architecture, it's predictable, it's easy to scale for, you know when to stop, you know when to start, et cetera. But we knew it was going to go to inference. And inference sort of changed the game, and we saw this with the release of o1. If you looked at the compute allocations for all other LLMs prior to that, and then you looked at the release of o1, it was really probably one of the first dramatic shifts that we saw moving towards the inference side. And while all of these discussions around policy and the benefits of AI are absolutely important, we should be having them, if we're moving to an inference or moving to an automation place, then the architecture becomes fundamentally interesting because it also needs to change. And so as we think about automation or agents, I don't want to get like into this religious philosophical discussion of whether something's an agent or we're just automating. I think those are just things to make people feel smarter. What we do is let's just break it down in simple things. What is an agent or an agentic or an automated workflow? It's fundamentally 3 components. The first component is how do I interact with the user, the AI, the model itself that's providing context, some series of workflows, and then some series of tasks that are typically exposed by APIs. So if I think about the architecture and what we need to deal with, this might be sort of an overall architecture. User queries either through voice or through chat. There could be a speech-to-text model. There could be caching and an evaluation to prevent things like prompt injection, cyber, qualitative type things. There could be one model. There could be multiple models. These models could be on-prem. They could be in a public cloud. They could be custom, et cetera. There's some complex level of orchestration, and that orchestration may manifest itself in rendering browsers, talking to APIs, accessing internal resources, vector databases, et cetera. All of this together is the thing that we're ultimately trying to do to solve a problem or augment the workforce. So we made a bet in terms of the first thing around architecture. In order to make this experience higher, you need a modern compute substrate. And so isolates represent a way to do true scale up and scale down beyond sort of what we see with traditional virtual machines, containers, Kubernetes, and even other runtimes. These are contexts that go inside of, if you will, a memory context, an isolated memory context. And the point that's really critical about these is that they scale up without any DevOps infrastructure tuning, and they scale to 0. And so when we think about governance and how we look at it, I don't need to pre-provision a bunch of GPU capacity, which I did when I was doing training, because when I move to the inference or the automation side, everything gets really spiky, everything gets really lumpy, and it gets really unpredictable. So I need something that can scale up, and more importantly, something that can scale down. And if I'm deploying these things in the public cloud, what I ultimately want to do is I want to reduce the wall clock time. If I'm using a traditional compute substrate, even in certain serverless environments that depend upon an underlying container runtime or an underlying VM runtime, then I spin that up and the agent goes and does all of these cool, wonderful things that Matthew McConaughey was talking about. I want to thank my friends at Salesforce because I just made the pitch to see if we could get them in our presentations. So I thought that was just really cool. All right. So now what we've got here is this idea that if I'm thinking about the economics of this for agencies, if you're deploying in the cloud, then when you start an agent, that thing's got to wait until all the returns come back. And the more complicated and involved it is, the longer that could take. An architecture based on isolates allows us to spin up the component of the application, spin it back down to 0, let the actions occur independently without having to wait for that and there incur the costs associated with it. The second thing after a modern compute substrate is what we need is a programmable global edge where locality matters and where it is automated. So this isn't just about running a model, let's say one of 50 or 80 or 100 or however many they're going to be open source models closer to the user for the interface. This is also the orchestration engine where the part of the app that interacts with other LLMs, maybe a constellation of LLMs or other APIs or rendering web browsers out in there. It has to be close to those sources as well. And so the more distributed these agentic flows look, and the more distributed these architectures can be supported by a global programmable edge network, the more we can drive a consistent and positive user experience. Now, from the standpoint here, the third thing I would say that we need to think about is we need to stop thinking about AI, agents, LLMs, these types of things as just an app or thing. We need to think about it as a technology primitive, and we need to ensure that all the other things, security, speed, acceleration, observability, logging, tooling, deployment frameworks, the more that we can tie those into a holistic approach to solving the problem that we want to solve, the closer we will get to realizing the promise of what these systems are talking about. And so if I go back to, the age of parachute pants, neon shoelaces, Ghostbusters, John Gage at Sun Microsystems said it best. It may have taken 40 years to get here, but the network is the computer. And when I'm talking about in the context of cloud-based services, it's that platform that's the computer. So I need something that's intelligent. I need something that's globally distributed. I need something that's embracing the most modern compute strictures that are out there in order to realize the promise of what we're trying to do. So the architecture is starting to awaken as these things become more prototyped and prototypes then move into production. We'd love to sit down and talk with you at Cloudflare about what you're trying to solve and how we might be a part of it. Thanks very much for your time and have a great day.